Yeah, thank you very much, and thank you to Pill.io for inviting us here to present today. My name is Karl, as you can see. I'm the technical manager for the Nordic region. I'm here with one of my colleagues today, Tommy. Where is Tommy? Sitting outside having coffee. Oh, that's typical. I think he expected me to go on in like 15 minutes, so maybe some of you could just go and give him a hint that I'm on now. So we are here, staying a little. I have to leave. I'm flying back to Denmark. Denmark is my base, so I'm flying back this afternoon. But I'll be here over lunch, and grab me if you have questions after this presentation. I was actually not supposed to be here, but my colleague who was going to be here talking about was one of our cloud architects in EMEA. He couldn't come because of personal reasons. So I was dragged in here. I was on vacation in Italy last week. So during this vacation we had some communication back and forth, and we decided on these topics. So I'll talk a little about hyperscale. I'll talk a little about power and cooling, because I think that's a really important topic. And I'll show you just briefly about open, because that's also a topic of today. I can pop a question, I guess. So how many of you are still deploying traditional servers in 19-inch racks? There are a few. We still do traditional servers for 19-inch racks, so that's also part of our story. So we do not only do hyperscale. But a little about who we are as a company. So this is just a short introduction to who we are. Until, I think, 2005, not many people in the world knew about a company called Lenovo. That was when Lenovo purchased out of IBM, as a big surprise to most people in the world, the laptop business or the PC business. So we do PCs, but today it's primarily laptops and tablets. Actually, we also do phones, if you knew that, I don't know. Primary brand here in the Nordics is Motorola, but it's owned by Lenovo and developed by Lenovo. We are quite a sizable company. We are China-based, as Inspur, our colleagues here, but we are a very international company, so in our board of directors and our management team, I think we have 7 different nationalities. We are traded 100% publicly on the Hong Kong Stock Exchange. I am representing a rather new group in Lenovo, the data center group, which was established in late 2014. We were also purchased out of IBM. We came over here in the Nordics in January 2015. And data center group is doing data center stuff, so we do servers, we do storage, and we do networking. So that's our business, and a lot of things has changed since we came over. To be honest, at IBM, the System X business we had back then was a dying business. It was not growing, and it was not the primary focus of IBM to drive that. They made a lot more money on the System Z and the power machines than they did on the traditional server business based on Intel architecture. We are growing fast, and one of the fastest growing parts of our company is actually the hyperscale part. For you using general servers, hyperscale may not be as interesting today, but it will be, as you heard from the presentation earlier, probably going to be in the future. The hyperscale customers of ours are most likely the same as the customers of Inspur. You saw all the names down on the list. We're dealing with quite a large part of them today. And to me, our hyperscale business is important because it's driving products faster to market. We use different thinking in the hyperscale market. and that also comes into the general product line. And I'll talk a little more on how the hyperscale servers are different from our traditional servers. Another area where I spend quite a lot of time is HPC. We talk about HPC, high performance computing, as the racing arm of Lenovo. So if you look at the car industry, Formula One is like the racing arm, of course, of the car industry. And a lot of things that comes first to Formula One later comes in our cars, like the brakes we all know today and we are all fond of. So HPC is driving things. We are challenged in HPC because of power consumption, density, heat removal, a lot of stuff. And we see those inventions that we do here drive also innovations in the other part of the industry. So that's really important for us. And on the latest top 500 list, you can argue if that's a good way of measuring who is the biggest in HPC. We took over the #1 position from our good friends at HP. I used to work for HP for 12 years before I joined this company. So I have a history there as well. So, and it's not because I came over that we today are #1. We have a strong presence globally. We have production manufacturing facilities in countries all over the world, or in regions all over the world: South America, Central America, North America, China, and today also, which is relevant here, opened 2 years ago a factory in Hungary. So we are producing most of the servers in our Hungarian factory today. Fast is important. I know that there was mentioned that Inspur maybe were the fastest to deliver the Perl-based platforms. We were also pretty quick. Intel has this early ship program, so even before it was launched to the general market, we installed 3,500 servers down at the Barcelona Supercomputing Center last year. If you ever have the chance to go to Barcelona, it's a nice city, you should try and book a visit to the Barcelona Supercomputing. It's the most beautiful data center in the world. Looks means a lot to the guys, and yeah, I just recommend you going there. One other thing that's important, I think, is we are rated as number 24 on the Gartner top supply chains. It's not only for IT companies, it's general companies in the industry. So that's a pretty good achievement. I think this supply chain capabilities of Lenovo, because we are doing a lot of this stuff, which is using a lot of the same components that we put in servers, that's also really important. We are doing have a lot of focus on performance in our servers, which is good for our customers. And if we look at our hyperscale business, I think it's even higher than the 95%. We had like a 97% on-time delivery last year, and the only reason we were down a little is that we had some accident with the transportation. So pretty impressive results so far. So a little about how do the general servers that we do build and sell, how are they different from the hyperscale? If we look at our traditional portfolio, which is called ThinkSystem, so these are the general servers. We have them in many form factors, 19-inch, all of them, but 1U, 2U, denser systems. We still do bladed servers as well. So that's the ThinkSystem brand. Then we have the ThinkAgile brand. That's where we put some solution design on top of the ThinkSystem servers. So ThinkSystem servers are still the foundation. When we do a ThinkSystem server, we need to do a lot of certification because the ThinkSystem servers need to support Windows, need to support Linux, different flavors of Linux. It needs to be tested. It needs to be certified with a lot of different components going into them. So we need to support traditional drives, SSDs, NVMEs, adapter cards, and all of these things are, of course, adding cost and takes time. So going fast to market with a server that needs to be generally supporting all of the things that that still is out there takes longer time than doing a hyperscale server. A hyperscale server, you sit down with the customer, you define the specifications, so this is exactly what you need, and then you build to that specification. So it may only have to support 2 or 3 different components inside of the servers, one type of drive, one type of network card, one type of operating system. It's a standard BMC in the hyperscale servers, so you use an A-speed BMC traditionally in most of them. And then the customer typically adds all the software on top of it. So it's just a different model from the traditional server business. And that you need to understand. We are offering today hyperscale servers to smaller customers than we did initially. But I think a general rule is that you need to purchase at least 100 identically spec servers per year in order to be a hyperscale customer with us. So that's the size, and that's where it starts to make sense to think of hyperscale. So traditional infrastructure, we still do that. We do software-defined data center, and that's primarily in the Think Agile brand. HPC and AI we also do, and there is growing demand for AI. If you're interested in AI, we have a team. So we see that many companies want to do AI, but they just don't really know how to get started. So we are offering customers AI workshops to get started. One of the challenging things to do AI is to get the people who can actually prepare the data. Most companies has a lot of data available, but how do you prepare those data and make them valuable? So data scientists is a necessity today, and they do not come cheap. We have a few data scientists. I can't claim we have many, but we have enough today to offer workshops, proof of concepts, engagements with customers who wants to do something in AI, to do something, get some value out of the data they already have in the company. And then hyperscale. So this is a slide that my colleague Pierre, who should have been here, would probably talk a lot to. So I'll just give you an overview of what we're doing when we discuss solutions. So these down here is the basic solution building blocks that we have. So the VX is for VMware, the HX is for our cooperation with Nutanix, and the MX is for Microsoft. So these are the Azure stack, the Nutanix, and the VMware certified nodes. Then we have a delivery and support model built around those appliances where we build them and deliver them and support them as solution. That's where we had this Think Agile appliance for VMware, and we have them here for Nutanix. But if you want to get to the full stack and provide a cloud solution, either internally or a hybrid solution, you have to add a lot of software on top of those basic building blocks. If you look at then on the Microsoft things that we've been doing, we were one of the early adapters for the Microsoft Azure Stack program. We And we have delivered some of these in the Nordics. So this is a Microsoft Azure Stack. This is an on-premise cloud where you consume just as you would have if it was the real cloud out there. So the difference here is that this equipment is in your own data center. But the way you pay for it is still based on the consumption model that you would if you purchased the services from Azure, from the Azure cloud. So Azure Stack. And of course this goes higher up this value chain. A lot of these services are already integrated, and you can start consuming when you get this installed. We don't have a lot of these customers. We have a few in the Nordics. I think we have 5 customers in the Nordics who have deployed this. And the customers who are really successful deploying it, they are also growing pretty fast. So it's an interesting area as well. And then the latest addition to this solution portfolio is a cooperation we have with a company called Cloudistics, where we are providing a complete stack, a turnkey solution here with our hardware, Cloudistics software, where you can buy your own cloud-ready stack. It's an on-premise cloud, but you add the ability of doing some composable things with this, and you can scale really modularly with this solution. So I'm a sales guy. This is all I know about this. So I can't tell you a lot more. But if you want to know more, grab hold of me or tow me, and we will make sure that you can talk to some of our specialists within this area. So back to hyperscale. Today we are working with 7 of the 10. You saw the 10, I think, all of them down here. You know who they are. The Facebooks, the Amazons, the Googles, the Microsofts, Alibabas, the Baidus, and so on. This is the fastest growing part of our company, and I'm really excited about this development, even if I'm not really selling hyperscale products yet in the Nordics. But maybe we'll do that in the future. This business is led by Paul Yu, who came over to us after he spent time with some of our competitors, Wang and HP. He's been driving the hyperscale business there. And he totally transformed this business. When we came over as System X to Lenovo, we also had a hyperscale business, primarily in the Chinese market. But we weren't successful, we weren't really making money on that. Doing more things, so what we believe that customer wants here is that they need something that's faster and flexible than a traditional OEM. So we can't just go use standard servers. What we did back then was that we went to these guys, the ODMs, and bought stuff from them and tried to resell into the hyperscale market. But then we were more or less competing with ourselves here, and it didn't make a lot of sense. And we also believe that we need to be better than just being a system integrator, which we more or less were a couple of years ago. So now we have a dedicated organization. We have good engineering resources. We're using our own supply chain. And I think this is an important statement as well, that we are the only company who are in fully control of the complete manufacturing and all the way up to the delivery and the service of the systems. So we do actually quite produce a significant amount of system boards. So we do everything from the system boards to the solutions that we deliver to customers. So this is how it starts. Sit down with the customer, engage, architect the solution, engineer the solution. We do the manufacturing from the basic print boards all the way up to the rack integration and delivery. And then we have a global organization who does the installation and service delivery around the world. We are represented in 160 countries around the world. And on the service side, we work together with IBM, as many of you will know, same as we've done successfully for the services for these small things here. This is more or less our products in hyperscale. We probably have more than just shown here. But if you look at these traditional servers, 1U, 2U, multi-node, GPU servers, I think it's not so important. We do support the standards in China and the global standards as well. We do support different rack sizes, widths, depending on what the customer wants. And as you saw from the presentation earlier, there are some differences in the rack designs also from customer to customer in this area. I had a slide covering this, right? Or am I remembering wrong? So I think I'll just skip this one. So, and I think also I touched on this. We're doing everything from component level, rack level integration, and then we deliver complete data centers. So, last slide about hyperscale. We design it, we build it, we deploy it. Now to another subject, power and cooling. And Paul, you mentioned here earlier a lot about this, the challenges the data centers will have in the future, especially on the cooling side. But I think the power is even more important. We are going to have, in my country, within the next 10 months or so, depending on when our Prime Minister will make a decision, a new election. And I'm afraid that election will be a lot about immigration, which it is in many countries. But I hope, it's my hope, personal hope, that it will be a lot about climate. And the first part of this, power, is really something that we need to be aware of. What do we do in order to make our data centers not just greener, but also to do some power reuse? I just Googled this topic yesterday. I found these links, and you will have these presentations, so you can go look at them. I think the first one is from Forbes, and we have someone from some of the universities, Stanford. I think this is a Yale thing. So this is a concern, and it's something that's been done a lot of research in this area, many locations around the world. And I think this statement that data centers of the world will consume 1/5 of the Earth's power by 2025. You can see different statements out there. This is probably not correct, but it sends a message, right? So it's important that we also think of this. So what is driving this? We were talking about Moore's law earlier, and if we have seen how Moore's law has been, you know, this is the performance of computers. We just took the spec FP rate here and saw where were we in 2006. And where are we going, where were we in 2017? Actually, the manufacturers of chips, CPUs, were able to keep the TDP, so the power consumption of the CPUs, pretty stable during this period. But now they cannot really put more transistors on those chips. Intel is challenged, even going down to 10 nanometers now. So the only way of getting more power from the system, and we all want more power, is to add more power as electricity. So you can see how the power just grows here. And what we see, this graph up here, or this picture up here shows, this is about where we are today. So we have typically CPUs in our servers today from 165 up to 205 watts. We are running, I think the highest TDP we are running in a data center in Germany at a large data center with about 6,000 servers. It's running up to 240 watt per CPU. You can do the math if you put, like, we have in the 42U rack, we typically have up to 72 servers with 2 CPUs in each, and then comes the memory and the I/O cards and the drives that also consume power. So it's pretty significant power draw from those type of racks. When we go to next generation, so this is current generation. What we expect from Cooper Lake, which is coming out in 2020, is to be from 205 and up to maybe 300 watts. If we look at the AI demands and the NVIDIA boards that are coming out, it goes even higher. So this is a real challenge, and we believe we cannot really do this with air alone. So blowing air across is not as efficient as doing something different. So we saw some pictures with water on the floor, and I think there was a picture on the leakage, but we have a pretty stable solution that can provide water direct to the nodes. And we believe that this is a fact today in HPC, and it will come to traditional data centers within the coming years. I'm 100% sure about that. We've delivered quite a number of systems to these customers. One in the Nordic here is Uninet up in the northern part of Norway. The large one is LSE. T-Systems is not a traditional HPC customers, are also deploying this. Other areas of the world also deploying these water-cooled systems. We are now today at the 4th generation of these systems. We started back in 2012 in the IBM days. Then we had a new system that came out just when we came over. And this is the latest generation. I have a better picture in a coming slide. So we believe that this is going to change the way we do servers and data centers. This is a picture of the server. This is a 19-inch, sorry for that, 19-inch server. Water inlet here, water outlet here. This is one tray, which is one node. This is the second tray, which is one node. These are combined together in order to save cost on the water loop. And the added cost is depending on the configuration, of course, because the cost of the CPUs are really a significant part of those type servers. The added cost to do water instead of air is about 6 to 8%. So, but what it means, that means that you can cool. Today we are cooling these 240 watt CPUs. We wouldn't be able to cool those in a dense system with air. It's efficient. We can remove, with the water here, we can remove up to 90% of the power consumption in the solution. We are not cooling today with water the power supplies. We are looking into different methods of doing that, but today it's just, we haven't gotten there. We may get there in the future. It's too expensive for us to do it today. The water-cooled power supplies are just too expensive. You get more performance from your system. You can run turbo always on these systems, and for some applications this means something. And then the inlet temperature of the water here is up to 50 degrees. So what comes out here is typically between 56 and 60 degrees. And if the return water from these systems is that high, it's really also easy to make reuse of the water. You can reuse the water to heat the surrounding buildings. You can. We also have other ways of doing it, but in Tromsø in Norway, it's the reuse of the water is used to heating the buildings at the university. So this is, I think, a really good way of getting something back from all the power you put into those components in order to drive the compute. So when we talk to customers, these are some of the values that they often look at. So yes, if my PUE is low, then everything is good. PUE may not be the best way of measuring this. You can also use this ITUE, or you can use total power usage. But I think this measurement will be something that will be coming to us. Energy reuse effectiveness. So how much of the energy you put in, you can actually reuse. And the ideal value is that you should be able to reuse everything. You'll never get to the 0, but if you can get below 1, I think you're on a good track. This is what you typically do. Put on the roof just some big blowers, and you blow all the hot air out in the surroundings. If you go up to Luleå, I think you can go with a thermometer and measure the temperature closer to the data center, and the farther you get away, the cooler it gets. So there's a lot of hot air being blown out of these data centers. Why not try to make good use of it in either the buildings or in growing some plants or having a nice swim in hot water? Right? So there's many ideas. One of the recent things that we looked into is we use these the warm water in this special equipment to actually generate cold cooling water for other equipment where we couldn't do this is for air-cooled chillers, right? Or air cooling chillers. So we did some absorption chillers that we put in the system, so some of the excess warm water we can use to produce cold water. It's not 100% efficient, I think it's 65% efficient, but still we make reuse of it. So that's another thing we're looking into. So we can do, of course, air-cooled, and most of the data equipment we deliver is still air-cooled. When we are challenged, we put rear door heat exchangers on those systems. We get the PUE down a little. You also have the direct water cooled, and the PUE is really good. And then if we can do some reuse of the heat generated, the warm water generated out of this, I think we are in an even better position. So let's see where the new regulations from the European Union comes out, if this is actually meeting some of these requirements. 2 slides. Thermodynamics. So why do we use water to move the heat away? Because water can transport heat a lot better than air can. So that's one thing. That's why we look at this technology. Why use copper, which we are using in the nodes, to transfer heat? Again, because copper is the most efficient way of transferring from the components to the water. So we want something in between the components and the water, of course, and that's why we use copper. Any guesses what this means? 40 kilowatts? Per rack, absolutely. But you already mentioned it, so you shouldn't be allowed to answer. I don't have any prizes unless I can take them. One last comment. I think I'm about done. I have half an hour. I think I already spent a little more, and I hope it's okay. So we are basically a hardware company, but you cannot really do hardware without doing software. So our software strategy is to be open. What we did when we came over from IBM is that we rewrote our entire management stack. So we are supporting open standards, redfish and other management standards. We also rewrote our network operating system, which we had on the network switches. We're doing quite a nice portfolio of network products as well. So now we have an open CNOS, as we call it, our Cloud NOS, and we are looking into, we just established a new business unit looking into more software-defined network type solutions. We are the main contributor to a product called XCAT, Extreme Cluster Administration Tool, I think was the name. It's a deployment and management tool. We did rewrite all these elements in Python, and these are made available to the open community. So just Google it. We have a Confluent project that's part of the same people who do the XCAT. They are adding some things to this. We also provide to the new Microsoft site here at GitHub some contribution. And if you go to this site, you can read more information about how Lenovo contributes software to the open community. If you want to see how this works in action, my colleague from the US, Jared Johnson, he did a video where he's talking about how you can manage and deploy servers using the tools up here. Have some time to, I think it runs for like 30 minutes, so if you want to go look at it, you need to set aside some time to do that. So that was an open message, and that was me. So thank you very much for listening, and again, thank you for inviting us here.